Hello everybody, I'm your drawing sir. Okay, we'll start the topic now. In the previous class, we have studied about cycloid. Okay, we have studied that cycloid means a circle is rolling on a flat surface or on a ground. Okay, now what we have did? We have traced a point P. Example, I am taking this one. This is a circle. Okay, if the circle is touching to the ground, I call it as point P. And this is rolling like this on a flat surface. Okay, this is rolling like this on a flat surface. Fine. After completing one revolution, it means the point P is touching on the ground for one complete revolution. We assumed that the distance traveled is 2 pi r, circumference of a circle, and we have traced the point P. Suppose this is the point P. Okay, stage by stage, while rotating, we have traced a point P like this for one complete revolution. Antena? That is said to be a cycloid. When we said it is a cycloid, if it is rolling on a flat surface. Okay, now another condition is there. What is that condition? That is what happens if the circle is rolls on another circle. If two circles are there, one is bigger circle and another one is smaller circle. Okay, now I am considering that bigger circle is a fixed one and smaller circle is rolling. Okay, then what happens? Then the same thing. If I assume this is a point P, the touching point. Okay, both are touching at certain point, and I will assume that this is a point P and rolling. This is the rolling circle. Okay, if it completes one revolution, then what I have to do? I have to trace the same point P which is touching, and again it will revolve for one complete revolution. Again, what about this distance? This is 2 pi r again. Yes. Now this path, the point P which is tracing, is said to be epicycloid. Okay, it is said to be epicycloid. If the circle rolls on the another circle, the point P which is tracing for one complete revolution from the circumference of a rolling circle, then it is said to be a epicycloid. Okay, I'll show you. What I am doing is I am drawing a bigger circle. Okay, I am drawing a bigger circle. You can see here clearly. Okay, fine. Now this is the bigger circle, and what I'll do, I'll take a smaller radius and I'll draw a smaller circle. Now see here, this is a smaller circle. Okay, now I'm considering after one complete revolution, this circle will come here. I'm considering that. I'm assuming that. Now I'll mark a point P here. Okay, now this is also point P. I'll consider P dash. Why P dash? After completing one revolution. See, this circle is rolling and coming up to here after one complete revolution. See, this is a bigger circle, is a fixed one. So I'll call it as fixed circle. Or I'll call it as directing circle. See, this small circle is rolling. So I'll call it as rolling circle. I'll call it as rolling circle, or I can call it as generating circle. I'll call it as generating circle. Okay, generating circle. Now what is happening? This is rolling and coming up to here for one complete revolution. Now what I'll do, see, from here I'll mark a center of this circle and center of both the circles. I'll join like this. Okay, and I'll join like this. See here. Now I have to trace what? I have to trace this point P like this. Now this curve is said to be what? Epicycloid. Now in the previous one, in the cycloid we have traced this is a flat surface, but here it is not a flat surface. It is not a flat. I cannot calculate with the scale the distance. This is a 2 pi r, no? I cannot calculate with the scale. So there is a formula, that is theta is equal to small r by capital R into 360 degrees. Now what we can get? We can get this theta, how much the distance traveled in the degrees, how much in the degrees, in the angle we can get. Now what do you mean by small r? Small r means radius of small circle or rolling circle, we can say rolling circle or generating circle. Capital R means radius of fixed circle or directing circle, we can say. So in this way we can calculate the theta, because this is not a flat surface. This is not a flat surface. I cannot calculate with the scale, not possible. So using theta I can say I can calculate the distance traveling of the rolling circle. Done. Let us come to the problem. See here, he has given construct an epicycloid in which the diameter of generating circle is 40 mm and radius of directing circle is 60 mm. Okay, and also draw normal and tangent to the curve. Now again I will come to here. What he has given? The radius of smaller circle he has given 40 and radius of bigger circle he has given 60. Yes. Now here what is my answer? I want this curve, that's it. So no need of this extra circle, extra part, no need. Antena? I don't require remaining one. Just I want this part of the bigger circle, and remaining about the smaller circle I want entire circle. So here in the diagram, in the answer, what I'll do, I'll draw just this curve of the bigger circle, and about the smaller circle I'll draw entire smaller circle. Okay, how to do? We'll see. First what I'll do, bigger circle means directing circle he has given 60 mm. So first I'll draw 60 mm. See here both are combined. See here, this 60, here 60 plus 40. So total length how much? 100. Antena? So first what I'll do, I'll draw the 100 mm line from starting point to ending point. Draw a line. I know that smaller circle radius is 40 and bigger circle radius is how much? 60. Just I'll mark this is 40 and this is 60. And next one I'll mark this is the center O, and I'll mark this is the center C. Okay, now what I'm doing, what is this? This is center O, and I have to mark the center C, because see here, this is 40 mm This is 40 mm kada, smaller radius for diameter anta 40 mm. Now what about the radius? This is 20. Ante kada, 40 lo half 20. So what I am doing, I am marking center C like this. Now what I'll do, from the center take 90 degrees line, very important, 90 degrees, mark a point 90 degrees. See, I am marking 90 degrees. Now after marking 90 degrees, I'll mark a radius. How much? The diameter is how much? 40. I am marking 40. See here. Okay, this is 40 and this is 40. Now what I'll do, I'll draw the circle now. Now in this way, I have taken a circle. What is this? This is the rolling circle. This is the rolling circle. Next, I have to calculate theta. Kada? Now, how much it is traveled? See here. This circle is how much it is traveled, that I want. So I have to calculate theta. So theta is equal to how much? Small r by capital R into 360 degrees. That is our formula. So theta is equal to small r, how much? Radius of smaller circle, that is 20. Capital R, how much? Radius of directing circle, that is 60 into 360 degrees. He has given 0 0 gone, 6 1 ja, 6 6 ja. So this is 120 degrees. Means this circle is rolling about 120 degrees for one complete revolution according to our formula. Okay, so what I am doing is, from this center O, see here, from this center O, bigger center, I'll mark 120 degrees. Now this entire length, how much? 100 mm. I'll draw the 100 mm line. I'll draw 100 mm line from here to 100. I know that bigger circle radius is 60. I'll mark here, and smaller circle radius is diameter is 40. Smaller circle diameter I am drawing, bigger circle radius only I am drawing. That we have to understand. Now let us come to this circle. Now what we have to do again, we have to divide this circle into 12 equal parts. See here, one thing what I did, this line and this line diameters should be 90 degrees, otherwise we cannot draw. Okay, now divide this circle into 12 equal parts. How to divide? I'll divide 1/4 circle. Okay, see here, 1/4 circle, we know the concept. Now this point as a center, take the radius, how much? This is 20. I am considering first quadrant. This point as a center, cut here, and again this point as a center, cut here. Okay, we have divided using the radius of the circle. Again I want to divide this part, this quadrant. So what I am doing, this point as a center, cut here, and again here. Two corners I am using. Now next what to do, just draw the lines from here using center. Okay, using center, right, like this. Okay, like this I can draw. Done. Over. Next point what I have to do is, I am sure that this is the point P. Okay, this is the point P. See here, this is the point P and this is the line. I will draw this curve now. Okay, what I am doing is, take the radius O as a center up to here. How much this is? This is 60. Antena, radius of the directing circle, I will draw up to here. See here, this is 60. The angle is how much? The angle is 120 degrees. I have to write here 120 degrees. This angle is 120 degrees. I am writing here. Okay, beside, I am writing beside. Now next, while rolling, this is rolling in the clockwise direction. Okay, I have to name this divided part. So this is the first point will touch this circle. So what I am drawing only one sector. See here. See here. I am drawing only this part, which is 120 degrees. Okay, done. While rolling, this first point will touch this one. This is the first point. And what about second point? This is the second point. Will touching this circumference of the bigger circle. Now this is third point. This is the fourth point, fifth point, sixth point, seventh point, eighth point, ninth point, 10th point, 11th point, and P itself is a 12th point. Okay, naming the divisions is very important. Okay, na? Done. Now what we did in the cycloid, previous cycloid, we have drawn a straight lines. See, from 11 and 1, see here in the cycloid, we have drawn from 11 and 1 straight lines. Okay, from 10 and 2, from 9 and 3, from 8 and 4, we have drawn what? A parallel lines. Here also we have to do it, the same thing, but not the parallel lines. What I'll do, O as a center, O to 11 as a radius, draw a curve such that 11 and 1 will touch. See here. Okay, like this I'll draw. Same O as a center, and again 10 and 2. Okay, again 10 and 2 I'll draw. See, O as a center, I have to draw everything. And 9 and 3. See here, 9 and 3 I am drawing like this. Okay, it should be very neat. 8 and 4. Okay, up to here. It should not exceed up to here only. Okay, next O as a center, 7 and 5. You have to draw arc. Okay, all the arc should be very light. And finally from 6th point. Okay, I have drawn from each and every point curve using O as a center. Now next what we have to do? See here, I have divided this circle into 12 equal parts. So this curve also I have to divide into 12 equal parts. Okay, and another thing is here, see here, in the cycloid, from the center line, see here, 9 and 3, 9, 3, the straight line, and center line is meeting 9 and 3, but the condition in the epicycloid is not same. See, I have to draw center line also. See here, center line will not match 9, 3. Here is different. So little bit dark I will draw for my recognition, easily recognition, for my clarity. See, center line will not meet. See here, but in the cycloid it is meeting because it is straight line. Because this is a curve, it is not meeting. Okay, done. One thing is different here. Now what I'll do, I'll divide this into 12 equal parts. This curve, I know that this is how much. This angle is 120 degrees. Okay, this angle is how much? 120 degrees. Now how to divide? This is 12 equal parts I have to divide. See, 120 degrees. How many equal parts? I have to divide 12 equal parts. It means 12 ones means 10 degrees. Each 10 degrees. So what I'll do? Put the protractor here. Now 12 equal parts means 10 degrees I have to mark. See, 10 degrees, 20 degrees on the protractor. Okay. Now this is 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees, 90 degrees, 100, 110, and finally 120. Okay, now what to do? From each and every point, I have to draw a line up to center line. See here, very important. Up to center line only. And then now I'll call it as this is C. Okay, next from O, from 20 degrees, second part, I have to draw like this. What is this? This is C2. 2. Now from O, this is C3, this is C3. Okay, from each and every point, what I am doing, I am drawing like this. All the lines should be very, very light. All the lines should be very, very light. See here, holding the pencil should be very, very light, not tight. You should not hold the pencil tight. Okay, from each and every division. Why we have divided this into 12 equal parts, this curve? Because we have divided circle into 12 equal parts. That is the reason. Okay, now naming them. This is C4, okay, C5, C6, C7, C8, okay, C9, C10, C11 and C12 finally. And what about this here? This is 1 dash. Yes, because this circle is rolling on this path. This path. That's why this is 2 dash, this is 3 dash, this is 4 dash, okay, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash and 12 dash. What does it means? 1 dash 2 dash means while the circle is rolling, 1 will touch 1 dash, C will shift to C1. Okay, while rolling, 2 will touch 2 dash, C will shift to C2. 3 will touch 3 dash, C will shift to C3, likewise and so on. If the 6 will touch 6 dash, what about point P? It will be exactly opposite. Antena? We have studied in the cycloid. So directly I can draw P6. Antena? See here, opposite. Exactly here, it will be P6. Directly I can show. Just I am marking. Okay, now what I will do, I have to trace the P points. Everything is same, just like a cycloid. What I will do, take the radius of the circle, how much, which is 20. C1 as a center, cut the first line, first arc. This is called P1. This is called P1. That's it. Same again, take the radius of the circle. C2 as a center, cut the second line. I'll get P2. Immediately name that one. This is P2. Next, C3 as a center. C3 as a center. Cut the third line here. This is P3. Next, C4 as a center. Cut here. This is P4. Fourth line. I am cutting on the fourth line. See, 8 and 4 are common line. So this is P4. I am marking as small x. Chudandi. Now next, C5 as a center. Cut here. Fifth line. Now this is P5. Next, C6 as a center. See, it will come opposite exactly. So this is P6. Now C7 as a center. C7 as a center. Seventh line. This is the seventh line. Yes, check here. Very, very important. This is the seventh line. This is P7. Again, C8 as a center. Eighth line. See here. Eighth curve. This is the eighth curve. Cut here. Now this is P8. Now C9 as a center. Ninth line. See here. This is P9. C10 as a center. 10th line. See here. This is P10. C11 as a center. Cut the 11th line. This is, see, this is the 11th line. So this is P11. And finally, C12 as a center with the radius 2 mm. I'll cut here. This is P12. Done. Join all the P points very, very carefully. P1, this is P2, P3, P4, P5, P6, okay, P7, P8, P9, P10, P11 and P12. So this curve is said to be epicycloid. Okay, fine. Now how to draw normal and tangent? Mark any point on this curve on the epicycloid. I'll call it as some Q. Somewhere I'm marking. ఎక్కడొక్కడ మార్క్ చేస్తున్నా. Okay, now take the radius of the circle. Take the radius of the circle. Q as center. Cut the center line somewhere. Okay, now I'm calling as this is R. This point as R. Now join R and O very lightly. R and O, and this line will touch this bottom curve. I'll name this is N. Join N and Q. Join N and Q and extend line. This is called normal, N dash. And perpendicular to the normal is tangent. This is T and T dash. Okay, this is said to be epicycloid. This is said to be epicycloid. I hope you have understood. Okay, thank you very much.